Hi, my name is Grant Van Patten. I'm here to talk about OCZ and Toshiba's new HMS technology. Just off the bat, HMS stands for Host Managed SSDs. The idea being here that you, the host in a data center, can actually control the background activities on an SSD. Now, what are background activities? Traditionally speaking, when you have an SSD, any SSD, there's a number of things going on in the background that control a lot of how the flash is managed. Some of those things are garbage collection, wear leveling, log dumps, trim commands. That's just a limited list. But essentially, there's a lot of things going on in the background that our firmware and other vendors' firmware handles that's out of the view of the host or the consumer or client. What HMS does is actually open those things up so they can then be managed and therefore coordinated across a large pool of SSDs. So especially in the case of garbage collection, these background tasks actually have a lot of performance impact and latency impact on SSDs as a whole. And so allowing a host to control, manage, and coordinate all of those things could achieve a much higher performance or latency benefit. So I'm just going to go through really quick how our reference design works, just to show you how you can actually achieve a performance benefit, and we'll just go from there. So let's see, we have your data, your incoming I/O data, and this is how I'm going to first show you how data normally happens in a data center, or I should say the data flow happens. So I'm first going to draw 3 little boxes here. Sorry for blocking the camera. And normally what happens is data flows in to these 3 drives, and outside of the purview of the host, each of those drives takes that data and writes it, receives read commands, things like that. And then while it's doing all of this, it's also doing all of these other functions. It's doing garbage collection, wear leveling, log dumps, and trim. And the drive and the host have no idea what the other is doing. The drive has no idea what data is incoming. The drive has no idea what data may be coming in the future or what data isn't coming if it's a lull time. And the host doesn't know what the drive is doing in the background. So what HMS does is it allows the host to control all of these background activities right here, so that across the large pool of drives, like I said before, when I/O is heavy, you can delay some of these or coordinate them to achieve much higher performance, consistency, and benefits. So this is the traditional model right here where drives take the data. Let me just go through really quick what it would look like in our reference design. And let me point out that actually it's just a reference design, and customers could then tailor it to whatever sort of workload or design optimization they'd like. Data incoming, now this is the HMS solution. Data would be incoming to 2 different drives, while the 3rd drive is actually doing all of these functions and not receiving any data in I/O. So these drives are waiting to do garbage collection, wear leveling, and other things. The 3rd drive is actually doing all of this at once. And then after a certain period of time, these drives switch, and it cycles through them all. So now this drive that was once doing all of these now gets back here and starts to do I/O. Next one in line is still doing I/O, but the one that was doing I/O originally is now goes offline and starts to do all these background activities. And by doing all these background activities in this cycled format, no drive is actually doing the background activities at the same time as it's receiving I/O. And by doing it this way, and like I said, in this cyclical fashion, we're essentially removing all of these performance hits from the entire pool's operation, thereby, like I said, increasing performance, but also performance consistency and the latency of the entire aggregated pool. So, like I said, that's our basic HMS design. And thank you for watching, and my name is Grant.